This is Scott from KIG. It's July 21st, 2016, on a beautiful sunny day out here in Clinton, Massachusetts. We're here in the front shop of KIG, where we have these 3 riedel chillers. We're running off for our friends and customer in New Mexico. This is the unit that we're going to run and demonstrate today. Before I turn the power on, we're going to go over just a couple things on the construction and the layout of the unit. As we communicated, these are basically 24 horsepower chillers, set up more or less like 2 12 horsepower chillers, almost side by side. What does that mean? That means that each circuit has its own stainless steel insulated tank. Each one of those tanks have a nice little sight glass, which can be seen through the slot in the panels. We obviously have all the panels. These are units that have never been used. Each tank has its own float switch there. Here's where the fittings are for the connections, but first let's come back over here. And from this side you can see the process pump for circuit number 1. And we'll get back in here too. Back here you see process pump for circuit number 2. So we have 2 12 horsepower compressors, and we have heat exchanger here for circuit 1, heat exchanger here for circuit 2. Each one of those circuits has its own thermo expansion valve, a hot gas bypass for low load conditions, and your positive shut off. If it's not calling for cooling, that circuit will be shut down. Technically it's one refrigeration circuit, but 2 heat exchangers, 2 tanks, and 2 pumps. And here's your thermo expansion valve. Did I say that yet? I'm not sure. So each circuit 1 and 2, obviously, as we said, goes back to its own insulated tank. And so what we have is we actually modified or simplified the piping here. So we have 2 connections here for circuit 1, which we call the CU circuit. That's for no other reason than that's what the original process it was intended for was referred to as the CU circuit, or copper. And the other circuit was called A1 or AL, however you want to look at it. So we just modified the piping a bit for commonality, and we're going to do that on all 3 units, so there's the same size inlet and outlet fitting for each of those 2 circuits. So those go back to, we have a nice little filter here for each one of the circuits too, and they have an element in there. You can run it without the element, but it'd be nice to run it with the element. Also, there's nice unions here in the front side of those filters. What we're going to do is open up the cabinet here briefly before I turn power onto the unit. And your 460 volt 3-phase power comes up from underneath the unit here. We connect here at the top of these overloads, and your ground is here. So we have our overloads here for the pumps, compressors, and 1 overload for all 4 fans. And then we have our contactors here for the pumps, 2 for the pumps, pump 1 and 2. These contactors for the compressors, and then 2 for the fans. So there's 4 fans. What does that mean? That's related to the kind of low ambient feature, if you will, if it gets cold outside. So one contactor controls 2 fans, the other contactor controls the other 2. So the pressure-based fan switching, if you will, has the options of 0 fans running, 2, or 4. Obviously 0 fans would be running at your lowest ambient conditions. This here is the controller power supply that we installed. That was the only thing really special about this unit, in that it was assuming it was getting its controller power from a process machine that it was kind of designed around. Other than that, it's a pretty generic refrigeration and chiller setup, with the exception that it's kind of, you know, two 12 horsepower chillers side by side. So I'm going to come back, video number 2 in a second. I'm going to power this up.